First of all, dear conference participants, I would like to thank the organizers on behalf of Infineum Latin America organization for the possibility to give a brief overview of the Brazilian flex engines experience and its sustainability pursuit. In these 20 minutes, I would like firstly to reflect on how the Brazilian passenger cars flex engine technology came to be what it is today, using bioethanol and bioethanol containing gasoline from its humble origins in the early 70s as a dedicated ethanol engine project, governmentally backed, to then briefly recap on the experience collected by Infineum on how to deal with the lubrication challenges posed by the high bioethanol containing fuels. Then thirdly, to elaborate on the upcoming efforts of the Brazilian OEM players to further improve the Brazilian passenger car sustainability, based on the fact that bioethanol derived from sugarcane is already a low carbon fuel, and also that in addition, the second generation bioethanol definitely would not compete with food. To finally drive some conclusions or observations about this energy transition path and how to make sure that it successfully achieves its sustainability goals. But let's start from the beginnings. Despite we can trace the early attempt to various initiatives along the 20th century, going from the forced addition of 5% ethanol to the imported gasoline back in 1931, to the use of 42% of sugarcane-derived ethanol in the gasoline commercialized during the Second World War in various northeastern Brazilian states. We cannot miss to highlight the key 1975 governmental initiative called Proálcool. That was a collaborative program between academic institutions, OEMs, and the government to promote in its first phase the anhydrous ethanol production in Brazil so it could be mixed with gasoline. Brazil was almost entirely dependent at that time on imports, which back in 1973, it had impacted the national budget deficit as a result of increasing oil prices. Through a mixture of fixed cost incentives and advantageous state bank financing, new ethanol distilleries were installed along with the sugarcane mills, which, with this offer of ethanol, then the vehicle repair and engine reassembly workshops were allowed to convert the gasoline engines to ethanol. However, with varied technical outcomes. The process basically called for changes in the cylinder head geometry to increase the compression ratio, more resistant valves and valve seats to cope with the greater fuel flow needed and temperatures, changes in the carburetors and the intake manifolds, and advanced ignition timing, the replacement of the steel fuel lines and fuel tanks to prevent ethanol corrosion. All of these in place, however, some materials corrosion issues persisted, together with cold start difficulties and gums formations in the carburetors. And this was combined with uneven qualities of the ethanol being offered in Brazil, which made the ethanol-converted passenger cars still unreliable and required specific action from the regulating bodies to improve this. Therefore, many engineering solutions were sought, and on 1979, the Brazilian government and ANFAVEA, the Brazilian Auto Manufacturers Association, signed an agreement to mass-produce vehicles powered by hydrous ethanol. This fuel would be priced roughly 2/3 of the gasoline price, and in parallel, tax reduction incentives for the ethanol cars were established. So the automotive industry geared up the research to develop ethanol cars. Auto parts suppliers also innovated, and finally, the first ethanol car was showcased in 1976 and commercialized in 1979. In this way, Brazil has established a convergence of interests at all stages of the value chain, from the ethanol production to vehicle offerings. by the local subsidiaries of the OEMs at the time established. However, it was not a straight path. By 1986, the crude oil barrel price plummeted from nearly $35 to $15. And this was a countershot that brought into question the ethanol substitution of the gasoline. From 86 to 1990, most of the independent sugarcane and ethanol suppliers fell into debt, which switched to a different activity, and the Brazilian government cut back its support for the Proálcool program, bringing it to a halt in 1999. In turn, between 1996 and 2002, the ethanol-only car production was practically zero. However, a big change was about to take place that would change things again. As a result of the launch of the flexfuel technology sensor technology in the late 90s, the first flex fuel engine was launched in 2003. And this was a big change. In 2005, just 2 years after the debut of the first flex car, the new technology was already present in 80% of the light-duty vehicles sold in the country. These flex engines can be used with Brazilian gasoline or Brazilian ethanol in any proportion, giving the consumers the flexibility to use either fuel, depending on which is cheaper at their location and time of the year. Various engineering innovations were incorporated to these flex engines during the last 20 years. From the fact that nowadays the electronic control unit adapts the airflow, the air-fuel ratio to deliver the required torque in a clean and economic manner. When a high percent of ethanol is detected in the mixture, a larger fuel injection is enabled by the fuel supply module, and then the fuel is pumped to the high pressure fuel rail. These systems are adapted to use port injections or direct fuel cylinder injection, and various additional sensors are included, like the crankshaft speed sensors, temperature sensors, NOx sensors, together with the key lambda sensor. Today is estimated as a result of the improvements that took place and the evolution of the market, that the sugarcane field occupies 9 million hectares, that is less than 2% of the Brazilian territory, of which 60% of the Brazilian land dedicated to sugarcane is intended for the ethanol production. And this was such a success that from 2003 to 2021, almost 37 million cars and pickup trucks are being equipped with these flex engines. Now, we should highlight that the high ethanol containing fuels pose, however, well-known lubrication challenges, such as increased fuel and water accumulation. It can lead to corrosion, increased corrosive wear, and clearly these challenges increase with higher ethanol contents in the fuel. For this reason, and to better understand these challenges in a systematic way, Infineum has conducted field trials using flex fuel vehicles running on E100 fuels, and the aim was to replicate short journeys where the engine is not getting to full temperatures before being switched off, which cause high fuel and water accumulation. Such accumulation resulted in the formation of white sludge that could be found in the oil mist separator, oil cap, rocker cover, and valve train, as well as the appearance of emulsions, which were found in the oil sump. The mechanisms of formation of the white sludge and emulsions are dependent on a number of parameters, including the proportion of water that may accumulate in crankcase lubricant, the method of emulsification, where it takes place, either by bulk homogenization, blow-by, droplet condensation, air entrainment, and the operating parameters at such engine place where this phenomenon occurs. Again, all of these challenges are proportional to the ethanol level. And it's also true that the appearance of these phenomena not necessarily result in what should be of most concern, which is actual destabilization of the oil, which can lead to TBN depletion and wear, corrosive wear. We should take into account that the Brazilian gasoline, it's actually the gasohol, nowadays is 27% of ethanol in what we call usually E27, and the user in these flex vehicles can use up to E100, which is the Brazilian hydrated bioethanol. But when the sludge and finally emulsions form, they can be accompanied by engine oil base number depletion, which may result then in further issues. And this is much more visible under specific cold and hot cycle operations. And for example, in the trial, ethanol and water contents were seen to increase, as we show in these two tests. And as it is shown in the bottom graphs of this slide, where the blue lines indicate a regime cycling more prone to water and ethanol accumulation in the sump. These demanding conditions have highlighted the importance of using finally corrosive wear. For example, in this slide, we show a comparison between two different oils, one that has been properly formulated to resist an accelerated TBN depletion or unaccelerated calcium depletion, and the other which clearly is not so resistant. Now, this may end up causing corrosion and corrosive wear. For example, in this slide, we may see how accelerated, corrosive wear is detected as the wear metals increase in the used oil. Again, we can see different trends on the oils if they are more prone to these phenomena than others which are more resistant according to its formulation. And an inadequate formulation will result in situations like we show here. Again, under severe conditions of the Infineum field test using E100 fuels, corrosions can be observed in oil 1. If you observe there is pitting in these surfaces, and this is believed to be a consequence of higher water and ethanol dilution that took place in the cold cycles, followed by the higher temperature drive cycles, which these higher temperatures in that portion of the cycles forces the water and ethanol of the engine oils, however, leaving acids that chemically attack the metal surface if the engine oil does not provide the protection needed. Again, this may come together with other situations. And Infineum experience highlights that thorough assessment of the hardware and the lubricant combinations under relevant conditions is required to deliver the effective solutions. And this is more relevant with the upcoming electrification of the flex internal combustion engines. one clear trend that is taking place is the localized electrification of the flex internal combustion engines in Brazil. The OEMs are faced with challenges on how to tackle the increased fuel efficiency mandates. For example, in Brazil, the governmental program called Rota 2030, that is 2030 route, set up limited tax incentives in 5-year cycles, and which first one was closed in 2022. Next one will be assessed by 2027. The third phase of these cycles is due to be assessed by 2032. And there is a decision here because, one path is to go for the full electric vehicle, a choice that some OEMs have made, seeking the harmonization with the global engineering plans. And while others have decided for localized electrification or hybridization of the flex internal combustion engines. Why? Various reasons. First, it is recognized that going the full EV route requires capabilities of the country electrical grid that are simply not expected to be in place in the next years, in a country like Brazil of continental proportion. Second, it allows the gradual build-up of the capabilities of the tier 1 suppliers. And thirdly, this gradual approach facilitates the transition of the auto industry, which realistically in Brazil will not be and will not have the large European governmental incentives to avoid a huge jump in costs, which would then be passed to the final consumer. Now, what this, in fact, will need, as in these hybrid flex internal combustion engines, the cycling of cold periods of operation causing further accumulation of ethanol and water, then proven engine oil formulations are needed. In summary, the flex engine vehicles are a technology that has now accumulated 20 years of experience since its launch. In the Brazilian case, the Proálcool legislation came together with other legislation forcing fuel economy improvements and the use of low carbon fuels. This in turn fostered the OEMs to make their choices. Some of them have decided going the flex hybrid route. And then it's important that if this is the route selected by OEMs, that the right lubricants are used to avoid any shortcomings. And Infineum is pleased to support the Indian auto industry with this. Last but not least, I would like to congratulate the Indian authorities for their interest in the Brazilian flex engines experience. And last but not least, I would like to acknowledge the kind support to this presentation of my colleagues, Simon Crick, Leandro Benvenuti, Dr. Raghuram, and Jinal Patel. Thank you for your time.